But I think we are now moving on to the next talk today.
Yep, and that was actually a good segue, as he mentioned CosmosDB, because our next segment coming up is surfacing FDA COVID data using serverless functions and CosmosDB. Up with Charles Chen. It's like we planned that.
Hello.
Hey, Charles. Welcome.
Hi, Nithya. Hi, Melody. Thank you so much for having me. Today, we will be talking about surfacing COVID data from the FDA using serverless functions and CosmosDB. And we'll be looking at a full serverless data processing pipeline to ingest any sort of data, in this case, data from the FDA. All right, so let's get started. So my contact information is right here. If you want to check out the app, you can go to CovidCureID.com to see the app running. And kind of like Davide showed earlier, we will be going through a full stack of how to build this type of application. So the session objective, we're going to do a deep dive and we're going to build an end-to-end serverless data processing pipeline. What we'll do is we'll extract the information from the FDA CAD's CureID database, load that into Azure Storage, use Azure Functions to perform the transformation and push that into a CosmosDB instance, and then serve it also from Azure Functions. So what is the FDA CAD's CureID application? This is a repository that was created by the FDA to house electronic case report forms for novel use cases of existing therapeutics. In many cases, you have doctors all around the world fighting hard to treat diseases. They're working with patients with diseases that are not commonly seen in the Western world. And sometimes they're using treatments that they have on hand or treatments that are available to try to treat these diseases. And the CureID application is a community-driven application where physicians all around the world can contribute electronic case report forms. Now, during the beginning of COVID, when the first outbreak started to happen around the world, this was one of the first places where physicians all around the world came to report their treatment regimens and report the results that they were observing. Now, again, this doesn't have just COVID data, but it has data of all sorts of disease areas. COVID CureID is my take on the application where we extract the information and make it just a little bit more presentable so that given an age and a gender of a patient, we can find all the different treatment regimens and drugs that physicians around the world use to treat the patients and find efficacious treatments so that doctors and patients can potentially find ways to treat COVID. Okay, so let's take a quick tour. This is the FDA CAD's CureID application. So you can see it's organized by disease area. And when you click into a particular disease area, you can see the different types of drugs that the doctors around the world, physicians, have used to treat their patients. And as you click through, it will list the different types of therapies that have been reported. But you can see it's very difficult to find exactly the information you're looking for, and the application is not responsive. So what I did is I built CovidCureID.com, which takes the same application from the FDA and makes the information a bit more accessible. So given the age and gender of a patient, we can find all of the cases that are in the CureID application and view it by the different therapies that physicians around the world have tried. And if we click through, we can see the different types of regimens that were given to the patient and quickly filter by whether they improved or deteriorated. And we could click through each of these cases and find details and additional notes. All right. This application is built as a full stack serverless application on Azure. So at the topmost layer is Azure Storage and static websites where HTML, JavaScript, CSS, and image files are hosted. Azure Storage with static websites is an excellent choice for building web applications because it is super scalable, serving your static assets directly from your Azure Storage endpoint. Not only that, it's incredibly cheap. So we're talking about fractions of a penny to run applications on top of Azure Storage static websites. And it also integrates easily with Azure CDN so that you have a true full front-end solution for building modern web applications. At the application level, we have Azure Functions. So Azure Functions, we are using it for both the REST API and also to perform data processing and ETL. Azure Functions, for me, is a Swiss Army knife and one of my favorite technologies. I've been working with .NET for 20 years, since the very first beta that came out. And I cannot be more excited about building solutions in Azure Functions. And of course, Azure CosmosDB. This is one of my favorite databases to work with. At the core of it, it is a super scalable, document-oriented database, but you can query it with a SQL-based API. There is a Mongo-based API, and there is also a graph-based API using Gremlin. So it is a multimodal database that gives you a lot of flexibility in how you can work with that data, and it's also super scalable. So why Azure Serverless? Some of you folks may be coming into the serverless world for the first time. Some of you are already experienced. I want to give you 8 reasons why I love Azure Serverless. Number 1 is a transition from DevOps to NoOps, right? So the beauty of Azure Serverless is you're no longer thinking about building containers or building virtual machines. As a one-man team, it's incredibly powerful because I don't have to think about DevOps. I don't have to think about operational considerations or deployment. Number 2 is focus on building code. So we saw it right at the introduction video. This is one of the biggest benefits of Azure Serverless, is that you can really just focus on building the code and not worry so much about the deployment, about the infrastructure, about building all of the surrounding aspects of your application. It's event-driven by design. And I think this is one of the trickiest parts for most people to grasp when they first touch Azure Serverless, is that it is inherently event-driven. And we'll see how this works when we walk through the code. And of course, ease of connectivity. So it's incredibly easy to build data processing pipelines using Azure Serverless because of the triggers that we can bind to our code. It's really a perfect solution for modern single-page applications. So we'll take a look at how we can use static web apps to host the front end. We'll see how we can use Azure Functions REST-based APIs to build our API for our front end. And of course, we have a fully serverless database in CosmosDB where we don't even have to think about a schema. We can push our JSON objects directly into our database. Hands-free scalability, right? So we can scale this application hands-free. We don't have to think about how many containers do I need? How do I configure my Kubernetes scaling to handle my application and scale it up and down? With Azure Serverless, the scaling is on demand. And consumption-based pricing. So as I've built these applications, I've paid fractions of a penny to host my applications. And it's particularly interesting with Azure CosmosDB because it takes this entire model and turns it on its head. Azure CosmosDB is priced by, it has multiple pricing models, but the most interesting one is it's priced by what are called request units per second. That means you pay $7 a month for 400 RUs per second. Now, whatever you build, if it can fit inside of that envelope of 400 RUs per second, you pay a fixed price of $6 per month. And of course, what's really great about Azure Serverless for anyone that's coming from a .NET background or a Microsoft Stack background is there are just really familiar developer ergonomics. And we'll take a look at how this manifests when we walk through the code. So let's talk a little bit more about the connectivity, right? One of my favorite parts about working with Azure Functions is the multitude of bindings that you get out of the box to connect different parts, different types of applications, and different systems. One of my favorite ones is the Signal R binding. This binding allows you to build real-time applications without a ton of programming whatsoever. In this application, this demo, we'll take a look at how we can use blob storage, CosmosDB bindings, HTTP bindings, and queue storage bindings to build a data processing pipeline that's going to take this data from the FDA and push it into our CosmosDB instance. Let's take a look at our data processing pipeline. So in this application, in the COVID CureID application, I've built an event-driven serverless data processing pipeline that's going to take the case JSON files, case data JSON files from the FDA website, and we can move it into blob storage. And once it's in blob storage, this will trigger a function that will kick off and perform some ETL, some light ETL, and do a distribution of that case data to 2 separate queues. We'll have one outbound queue for the different regimens, and we'll have a second outbound queue for each of the drugs that are part of those regimens so that we can view the data by drug and also by regimen. Once it's in the queues, we can use a queue trigger to trigger the different functions to perform additional transformations or additional processing and push those right into CosmosDB. Now, as we look through this code, what you really want to take note of is that we don't have to write a lot of the underlying connectivity to get these pieces working together, okay? And if you're interested in working with the full database, you can email curesupport@nih.gov to get the full database to work with it yourself, okay? Let's dive into the code. So number one is how we fetch the data. There's a simple script, and if you'd like to see, there's the code is fully hosted in a GitHub repo. So you can have full access to how all of this is set up. But first is fetching the data. We have a simple JavaScript file that we can run from the command line to fetch the data from the FDA CureID website. Once we fetch the data, we use a set of Azure CLI commands to load that data. This Azure CLI commands will also create the assets in Azure. You could use technologies like ARM templates. You can use Terraform or other technologies to deploy these assets. But for me, my personal preference is to use the Azure CLI. And this simple script will configure all of the artifacts, whether it's local in your local development environment or in Azure. Now, once we have this configured, we can start to write our data pipeline. This data processing pipeline, you can see what's really interesting about it is that it's just a regular class. There's nothing special about it. I don't have to inherit from some class. I can just write a regular class. And once I've written this regular class, I can decorate it with this function attribute. This function attribute indicates to the runtime that this is a function entry point. And we have these attributes here that indicate that this is an inbound trigger from a blob storage endpoint and an outbound trigger to two separate queues, right? Now, when I start to receive information, when the first file gets dropped into blob storage, this will kick off this function. And you can see I can start processing my data right away, and there's no connection that I have to make to the queue. I simply drop my data into the output collector, and that automatically pushes it into the queue. And once it's in the queue, I can pick it up with a separate function here to process each of the entries, each of the regimen entries, using a queue trigger, listening on that queue. And once I have that information, I can do any additional transformation or processing that I need to do on my data before dropping it right into CosmosDB. And you can see there's no connection code necessary. All of the connectivity between these different elements in the Azure Serverless ecosystem is handled by these trigger bindings. So this is an incredibly powerful, streamlined way to build data processing pipelines without having to mess with the complexity of connecting a multitude of endpoints in your code, and really cleans up your code so that you can focus on working with your data. Now, in this case, we're just doing a very simple ETL. And for that, Azure Functions is a perfect tool. It's lightweight, it's incredibly easy to work with, and you have tons of options for pipelining that data in and pushing that data out. For any sort of heavy lifting, you'll want to consider Azure Data Factory if you're doing large data streams, or if you're doing heavy-duty transformations, or you want code-free, no-code transformations. Let's take a look at how we're doing this transformation in Azure Functions. In this case, when we receive the case file, we just have a simple function here that takes the information in that JSON and starts to flatten that information down. So we're just doing a very simple JSON transformation to take a very complex JSON document and making it a very flat JSON document. Azure Functions is the perfect tool for this because we don't have to learn a multitude of tools. We don't have to configure a large system to be able to perform these types of very simple data transformations. And we can also run these data transformations locally. Now, let's talk about querying this data. Once we have it in the database, how do we get it out of the database, right? For this, we can use the repository pattern. Repository pattern is a perfect fit for the Azure CosmosDB because it is a document-oriented database. Let's take a look at what this looks like when we have the repository pattern. In this case, this is my drug repository class, and the drug repository class simply maps to an entity type that I have in my CosmosDB. And you can see one of the great things about working with CosmosDB is that even though it is a document-oriented database, I can work with this database using familiar technologies, familiar paradigms like SQL. So I can query my CosmosDB using the SQL API. I can use the MongoDB API, or depending on my workload, I could also use a graph database API called Gremlin. In this case, I have a very simple query. I can parameterize it, and I execute this query and get the results back. Now, if I'm working locally, I can also run the emulator. So CosmosDB comes with a local emulator. You can also run the emulator in a Docker container if you're working on Mac. And this emulator allows you basically get a fully functioning Azure CosmosDB on your local machine where you can build anything you want without paying a single cent. Now, you can see we can write very simple SQL-like queries. And in this case, we're going to find and count all of the different cases by country. And if we execute the query, we can see all of the different cases that were reported from all of the different countries around the world. What about the front end? So Azure CosmosDB Azure Functions is not just a ETL or data processing pipeline, but it can be the foundation of building your REST APIs. And it's a great solution for building REST APIs for a number of reasons. The first reason, of course, is that you don't have to think about scaling your APIs, right? So even as your number of users increases, the Azure Functions runtime itself will handle the scaling of the API of the runtime instances for you, right? Number two is if you're like me and you build a lot of enterprise applications, Azure Functions is a great solution. If you think about your enterprise applications, they tend to have peaks and troughs during the day, right? So you'll have very high usage when people come online very early in the morning. You'll have potentially very high usage in the afternoon as people come back from lunch. Then at night, your application usage completely drops off, and your servers, if you're using virtual machines, are just sitting there idle. Azure Functions is a perfect solution for building these types of enterprise applications because it automatically scales up and down with the usage of your system throughout the day. And if no one's using the application at night, it's just going to sit there and you won't be charged. In this case, you can see here, we have two HTTP endpoints that are receiving requests from the front-end static web app. And you can see what's really nice about it is that if you're already familiar with .NET Web APIs, it's really familiar to write the same applications in Azure Functions. In this case, we'll have two APIs that each map to one of the repositories and retrieves the information from CosmosDB. Let's take a look at these. So in the data provider, once again, you can see my Azure function is just a normal class. And you can write these classes either as static classes, as you'll see in most of the online examples, but you can also write these classes as instance classes. And if you write them as instance classes, one of the benefits you get is that you can take advantage of dependency injection. So right at the beginning, at the keynote, John talked about being able to use an in-process and out-of-process model. I believe with the out-of-process model, you can use the full middleware of ASP.NET. However, if you're using in-process, you have to fall back on the dependency injection capabilities of the in-process model. And in this case, in our app startup, we can initialize our Cosmos gateway and our repositories and put it into our services container and access those as injected instances in our Azure Functions. Now, you can see the Azure function is super simple. All we have to do is decorate our function with a function name attribute and an HTTP trigger that says this function will react to an HTTP event from a client. And we can use get, we can use post semantics, we can declare the route, and within that route, we can parameterize it. And what's really great about Azure Functions is that if you're using .NET, or the Java API, you get these strongly typed parameters by default. So you don't have to guess, you don't have to process and pull this information out of the forms or out of the query string. You can just work with strongly typed data. And my personal preference is to keep the functions simple and move most of the data processing logic into domain models. So in this case, you can see we have a very simple entry point that's reacting to an HTTP event. And we simply execute the query and return the results. For anyone that's familiar with .NET Web APIs, this should look instantly familiar, right? There's nothing magical here, and that's what makes Azure Functions a great platform to build the next generation of web APIs. One of my favorite parts about working with Azure Functions is that you can build and test locally. There's no cost or commitment. You don't need to sign up for anything. You don't have to provide a credit card. You can build these types of applications completely locally using completely free tooling, whether you're on Windows, you're on a Mac, you're on Linux. You can run many of these components in Docker. And you can build using the language of your choice. So C#, obviously my favorite. But if you like F#, JavaScript, Java, PowerShell even, Python or TypeScript, you can use the language that you're comfortable with for building .NET serverless, for building Azure serverless applications, okay? And I also want to show you how we can take advantage of some of these developer ergonomics that we're all used to already. So for example, within this workspace, within my Visual Studio Code workspace, I can debug my application and use an F5 development experience if I want to use it that way, right? So just by clicking my start button, it will build the application, attach the debugger, and I'm ready to go. So you can see here, it's cleaning my application, it's built it, and it started the functions runtime. And now if I use my local instance, it'll step right into my debugger, and I have full access to look through my local variables and my call stack. So Azure Functions for me is a great development experience because you can work with the tools that you're already familiar with, work with the developer experience that you already have, decades of experience with, and the ergonomics just feel very familiar. Now, if you like to, you can also run this from the command line. So for example, in this case, simple as running func start, and this will also start my functions runtime. And now I'm ready to go once again with my functions running. On the left-hand side, you can see here, there's also this Azure extension that you can install with Visual Studio Code that gives you full access to see the functions that you're working on, and also access to your local storage so that you can explore the different files that you're working with. Now, earlier we talked about working with Azure Functions and why Azure Serverless is such a great solution. Of course, one of these is DevOps versus NoOps. And my favorite part about this is that working with Azure Functions and Azure Serverless, I have a really streamlined path to deploying my code right from GitHub, right? So from Visual Studio Code, I can build my GitHub actions. I can specify my GitHub actions. And from my GitHub actions, I can respond to push and pull requests and automatically deploy the code into Azure. Now, I've separated my deployment into server and API, into API and web front end. So this means that as I'm building the application, I can separate my deployments. So I can have front end deployment separate from my back end deployment. And if I make a change to my application, all I need to do is commit and push, and this will trigger the build on the server side in GitHub and push into my Azure storage. So let's do a quick example. Let's make a small change. All set, and Now, as soon as I push this into GitHub, this will trigger an action to start building and deploying the application. And because I've separated my actions from the server side and the front end, I can deploy the two separately. I can deploy just the front end or just the back end based on which side of the application has changed. Now, what's really great about this integration is, of course, if you're using Azure Static Apps, web apps versus Azure Static Websites, right? Azure Static Web Apps pulls all of this together for you automatically. With Azure Static Websites, you have to do a little bit of the work yourself. However, I've taken the initiative and written down how you can set up this type of application yourself from the very beginning, how to build the function app itself to the different commands you need to use to pull all of this together. And one of the key parts of this is during this build process, we can inject secrets into our application that include the API endpoint that we are hitting from the front end, from the static website, our Azure credentials, and our Azure function publish profile. We can take all of our secrets and move them out of the code and inject them at build time. So this code is made open source, and you can download it, and you can start building with it locally. Again, one of the best parts about working with Azure Serverless is that you can build in the language that you like to work with, that you're comfortable building with. You can build it in any environment that you are comfortable with, that you have access to. And there's no cost or commitment to get started and learn these technologies. And of course, the best part is that if you're already an experienced .NET developer, it's incredibly easy to make that shift from your ASP.NET web APIs that you're building today to Azure Serverless APIs that can scale, that have all the benefits of building Azure Serverless solutions. All right. So if you're interested, you have full access to the application at COVIDCureID.com and, of course, the GitHub repository. Any questions?
That was excellent. That was very exciting.
Thank you.
I think most of the questions were actually answered either by you in your session or in the chat already. I didn't see any new ones coming in just yet. I really enjoyed how you were saying how easy it is to integrate, and of course, how CosmosDB is easy to use and to integrate with CosmosDB. That's
and I think
one of my favorites.
I think the best part of it is that if you already have very strong backend skills in SQL, you can take those skills and it translates very easily using the SQL API, right? If you don't want to be adventurous and start using the Gremlin API and writing graph queries, right? You can take the skills you're already familiar with and translate those into the Azure platform.
Yeah, whether that's front end or back end, as you were saying.
Whether it's front end or back end, exactly.
Yeah, I really like that.
Yeah, I really liked it also because it's a completely open source project. So I'm going to encourage people. I know Hacktoberfest is coming up, but I think this is one of those projects where you can learn from how you built the system, use it on open source data, and take that pattern and apply it to like a different problem, or maybe just contribute back to the same one. This is a really amazing project.
Definitely one of my drivers. Number one was during the spring of 2021 to find some way I could contribute to how we were handling the COVID situation, but of course also contribute this application as a pattern to the community, so that folks that are building data processing pipelines, folks that are already familiar with ASP.NET and want to build the next generation of applications on Azure Serverless in cloud, they have a fully functioning application that they can download and start building with.
So I know this is probably not relevant, but is there any kind of issues you have to deal with because this could be sensitive healthcare data?
In this particular case, the information is fully available from the FDA and from NCATS. So you can email Cure support at nih.gov to get access to the full database, and they will email it to you. You can also access the information through the website.
I love this case study. Super awesome, and I can't wait to see where it goes next.
Thank you.
Yeah, that definitely makes it an easy case study to use, because typically when people want to do something like this, it makes it difficult having access to data to get them started. So this will make it easy for everyone.